All right, guys. This is the next section in Chapter 8. Once we get to Section 4, you'll no longer need your flip book. The topics are kind of what a math person would say is mutually exclusive in that way. We're not going to be graphing them anymore. We're going to be doing more math with these problems, okay? So I'll just kind of need you to get your mind out of that mode and learn this new thing and realize that it's kind of like a brand new topic, okay? I'm going to turn my screen this way a little bit to be able to see me a little better. I'm going to get a little bit more comfortable here. All right, so this is what's called multiplying rational expressions, which basically means that we're going to take fractions and we're going to get them in their simplest form by canceling or reducing and canceling things. So first I want to give you a quick little mini lesson on what can and can't be canceled in a fraction. In order for things to be eligible to be canceled in a fraction, there must only be multiplication going on between that thing and everything else. Okay, and everything else. And I'll give you a quick example by doing this. Okay, let's say we had something like x plus 2 over x plus 5. Now, what a lot of people will mistakenly do is say, oh, there's an x on top and x on bottom, they'll cancel it. Okay, and I'm going to show you why you can't do that. So, number one, the reason why you can't do it, what you want to remember is that the only way that you can cancel something is if there's multiplication going on between that thing and everything else that's on that side of the fraction. So this x has an addition sign next to it, which right away makes it ineligible to be canceled. Okay, let me show you why. If I would be able to do this, which I can't, then I would be saying that this original fraction is equivalent, which means no matter what number I plug in for x, I'm trying to say it will always be 2/5. Okay, well, that's just simply not true. Let's say today my favorite number is 3. Then when I plug in a 3 for x, I would have 3 plus 2 is 5 over 3 plus 5 is 8. And 5/8 is not the same thing as 2/5. Okay, now, contrary to that, let's kind of switch this up a little bit. I'm using the same numbers, but a different math operation. Notice that there's only multiplication going on between this 2 and this x. There's only multiplication going on between this 5 and this x, which makes the 2 and the x, the 5 and the x eligible to be canceled because there's only multiplication happening on the top and the bottom. So in this case, I can go like this and say that, yes, this is equivalent to 2/5. To prove that to you, again, let's say my favorite number is 3. 2 times 3 is 6 over 3 times 5 is 15, which this is equal to 0.4 as a fraction, and this is equal to 0.4 as a fraction, showing you that, yes, these two things are equivalent. Okay? So let's start to try one of these. Hopefully, when I do these, you'll understand more of what I'm saying. There's basically going to be a two-step process to do these. The first is going to be to factor everything. Okay? John Rick can help you do that. You might be really good at factoring, but if you struggle, John Rick can always help you. And then 2 is going to be to cancel things that are on top and bottom. If you have the same thing on top as you do on bottom, you can cross those things out and cancel and reduce the fraction. Okay, so let's first start with this one. All right, now, let me just show you again. This x squared, see, a lot of people will go and try to cross out these x squares. No, because that x is there only multiplication going on between that x squared and everything else up top? Well, obviously not, because there's a plus sign sitting right next to it. Okay, this 7 is not eligible because there's a plus right next to it. This x is not eligible because there's a plus right next to it. So none of this is eligible to be canceled because there's a lot more going on up here than just multiplication. There's a lot more going on down here than just multiplication. Now, what's going to create multiplication is factoring. Okay, so you can type this into John Rick, or this one's not hard. I'm looking for two numbers that multiply to be 12 and add to be 7. That would be plus 3 plus 4. Now, look what I just did. Look what factoring just accomplished for me. I took this thing, which was 3 terms, none of which were eligible to be canceled because there was addition signs in between, and I turned it into a multiplication problem. I have this parenthesis, let's call this parenthesis A, being multiplied times this parenthesis B. So since there's only multiplication going on between this parenthesis and the other one, then this parenthesis the x plus 3 as a group, as a unit, is eligible to be canceled. This x individually is not, because there's a plus sign next to it. But the x plus 3 as a unit, as a binomial, is eligible to be canceled. The x plus 4 as a unit, as a binomial, is eligible to be canceled. Now down here on the bottom, I'm looking for two numbers that multiply to be negative 28, but add to be negative 3. That would be x minus 7, x plus 4. Now, I have an x plus 4, it's eligible to be canceled on top, and x plus 4, it's eligible to be canceled on the bottom, so I cross them out, and I'm left with x plus 3 over x minus 7. Okay. Let's see. The next one we could do could be something like, let me find a good one for us here. X squared minus 5x plus 6 over x squared minus 4 times x squared plus 3x plus 2 over x squared minus 2x minus 3. Okay, here we go. Factor time. Factor time. On the top there, the left, it's a trinomial. I'm looking for two numbers that multiply to be multiply to be positive 6, add to be negative 5. That's minus 2 minus 3. On the bottom, that's a binomial. Binomials either have GCFs or they're a difference of squares. This, in this case, is a difference of squares. I square root the front. Square root of x squared is x, right in front. I square root the back. Square root of 4 is 2. Make 1 plus and 1 minus. Top of the right numerator, I'm looking for two numbers that multiply to be 2 but add to be 3. That'd be plus 2 plus 1. On the bottom here, I'm looking for two numbers that multiply to be negative 3 but add to be negative 2. That's minus 3 plus 1. After I factor, now look, again, first of all, there's only multiplication here, and then there's only multiplication. So you can just consider this now to be one giant fraction. Okay, you don't have to worry about if one's on top of the right fraction but bottom of the left fraction. Like, look, this is all this is on top, all this is on bottom. So I've got an x minus 2 on top and an x minus 2 on bottom. I got an x plus 2 on top and an x plus 2 on bottom. X plus 1 on top, x plus 1 on bottom. X plus 3 on top, x minus 3 on top, x minus 3 on bottom. It all canceled. That gives me an answer of 1. We'll try two more just to show you some different types of factoring here. Okay. How about this? 2x plus 12 over 3x minus 9 times 2x minus 6 over 3x plus 8. I don't know if this one's going to be good, guys. Sorry, this one looks a little weird. We'll see what happens, okay? So binomials, either difference of squares or GCFs. This one is a GCF. The biggest number that divides 2 and 12 is 2. And I'm left with x plus 6. Again, binomial, this one's a GCF. The largest number that divides 3 and 9 is 3. And I'm left with x minus 3. Again, binomial, GCF, I can pull out a 2. This is nothing, it's just 3x plus 8. So I've got an x minus 3 on top, x minus 3 on bottom. Now, you don't need to do too much math here. You never need to refoil. I do know that 2 times 2 is 4, and then I have my x plus 6. On bottom, I've got 3 and 3x plus 8, and that's done. I don't need to refoil that or think I need to distribute that. Okay, I just leave it factored. That's its most simple form. Okay. The last one I want to try to do with you, just to make sure you understand, I think these are simple, but sometimes when I don't do an example, people will get confused. Is one like this. First of all, know that all of these things are eligible to be canceled because there's only multiplication going on. 4 times x squared, only multiplication. Times, still multiplication. 7 times y, still multiplication. Same thing going on down here. Okay, so y's gone. I have x squared on top and x to the 4th on bottom. So this x squared can cancel out 2 of these, so I'm just left with x squared on the bottom. And now I want to reduce these numbers because I see that they have a GCF of 4. So 4 divided by 4 leaves me with a 1. 12 divided by 4 leaves me with a 3. So now on top I have 1 times 7 is 7. On bottom I have 5 times 3 is 15. And then I still have my x squared. And that one's done. Okay? Don't forget you can use John Rick. Don't be afraid of factoring.